Hi, this is Dr. Dan, and I'm going to show you how to make hydrogels that we can photocrosslink using methacrylated gelatin. So I actually did this interspersed when I was making the normal agarose and gelatin hydrogels, so it may feel a little jumpy and like I'm splicing things together because that's what I did.
All right, for our methacrylated gelatin, we need a couple things. Number one, we need a gelatin, and number two, we need a photoinitiator solution that we're going to dissolve it in. Okay, and so I've already had a photoinitiator solution, but I'm going to get the things we need. And so I recently purchased this methacrylated gelatin. I did a couple tests to make sure it would work. And so I can make a gel at 10% weight to volume out of this. And so that's what we're going to do. The thing is, this is only 1 gram of methacrylated gelatin. You can see it's really airy from when they lyophilized it or freeze-dried it. And it was $200. So that's why we can't normally do it during the regular semester, because we don't have that kind of money for everybody to be able to photoinitiate, make photoinitiated gels like this. But this is one of the advantages of me doing it for everybody, is you can see how we can do this. Okay, so we're going to use this methacrylated gelatin. I'm going to start working over here a little bit where things are a little darker. We do want to not prematurely crosslink things that have these acrylic groups on them. And what we're going to use for a photoinitiator is this combined substance. So first I'm going to start with this HBS, which is Hepi's buffered saline. And that's just something I made from a recipe I've had for a long time. And it also contains 1.5% TEOA, which is triethanolamine. And that's part of the photoinitiation process in this system, because we need those amine groups. The other thing we're going to add to it is 1 millimolar of EOSM-Y. EOSM-Y is our photosensitive dye. It is actually a pH indicator, but when light hits it, it will, it's actually green light, so 514 nanometers hits it, and so that's why we can use white light for this. It will cleave and start the photoinitiation. The other thing we're going to use is something called N-vinyl pyrrolidone. And this particular bottle says 1-vinyl 2-pyrrolidinone. And really, the 1 and the 2 determines where the chemical groups are, and it doesn't really matter. So we usually call it N-vinyl pyrrolidone, or NVP for short, because that 1 can be any number, really, wherever the group is. So the way we mix that is for every 1 milliliter of the HBS and TEOA, I'm going to add just 10 microliters of this 1 millimolar EOSM-Y solution and just 3.5 microliters of the NVP. The NVP is toxic at full strength, but when you dilute it down to 3.5 microliters out of 1 mil, it's much safer. So yeah, we'll have to do this in the fume hood. But I keep the HBS sterile because past experiences have showed me that you can store this for years, but if it gets bacteria in it, it tends to promote the growth of bacteria, and so your solution will get really gross. And so it doesn't have to be sterile because if we're not using it for a sterile purpose, but it has to be sterile because if bacteria gets in there, you can't store it very long, and it'll start to get gross and it won't work as a photoinitiator. So whenever I get some of this out, I do it inside the biological safety cabinet to keep this as sterile as possible. Okay, so I know I probably need about, I'm just going to overestimate and get about 8 milliliters of photoinitiator solution. So I'm going to get 8 milliliters of that. For every 1 mil, I need 10 microliters, so I need 80 microliters of this EOSM-Y. And then 8 times 3.5 is 28 microliters of the NVP, right? Took a second to do the math. Okay, so I'm going to go ahead and get this out in the biological safety cabinet first. And we're going to take our 15 mil tube with us. I've already set up the biological safety cabinet. Spray down with ethanol. Okay, so 8 mils, we're just going to use these pipetters. I'm just using even though we're not using cells, I still want it to stay sterile, so we're going to use all the normal sterile technique that we have used in the past. Okay, now I can take all this stuff out. Okay, and so this, you can see this is not covered in foil yet because it's not photosensitive. But as soon as I add the Eosin Y and MVP, it will be photosensitive. So I'm going to go ahead and get some foil to cover this. And we're going to be using lots of foil to keep our photosensitive things from being prematurely exposed to light. Now I'm going to just get some tape to tape this one down. I'm going to go ahead and tape it at the top here. Of course, I'll label it to make sure we know what it is. I'll call it PI buffer for photoinitiator buffer. And then we're going to take this into the fume hood. So part of the reason I'm doing this is because it's darker over here, but the other reason is, as I said, that MVP is a little bit dangerous. So all right, so we said we needed 80 microliters. Part of the trick in this is making sure you get in the liquid when you can't see. Okay, so just 80 microliters. I'm going to just pipe that up and down a little bit to make sure it washes out everything. And then we said 28 microliters of MVP. And I want to make sure I get down in there, so I wash this tip out and get all the solution. Okay, so we have our photoinitiator buffer. Now you may be wondering, okay, what about the tip that I had in the MVP? Well, so that's another reason I washed it out. Like, we diluted it quite a bit when we washed it out in this, but I'm going to leave it in here to kind of evaporate any MVP that might be left. And that way, when we throw it away, it's safe. We're going to weigh out the rest of this, and then we're going to dissolve it at 20% as well. And so that's going to be a little bit difficult to do. And so that's what we're doing with the water bath. So because it's going to be a much smaller quantity, and we won't be, like, if you have 1 gram, right, 20% solution for 1 gram, if it is all 1 gram, how many mLs is that? Right, and so we can't really put that in a big bottle to dissolve it. All right, and so I'm going to just weigh this out into this 15 ml tube. Sometimes the tube cooperates, sometimes there's too much static. All right, so we tear the weight of the tube, and then we want to weigh how much this is. So this is a little bit difficult. I can already tell you because it's like these big blocks of freeze-dried material, so I'm going to have to break it up a little bit, and I'll put it into the 15 mil tube. Okay, and I got out as much as I could, but you can see it kind of filled up already, so we're going to see how much that actually was. All right, so that's 363 milligrams. Okay, I want to dissolve this at 20%. All right, so let's go ahead and do the math on that. Okay, this is also methacrylated gelatin, which is photosensitive, so I'm going to quickly kind of cover it in my foil, just like I did with the photoinitiator buffer. So the tricky part about this is it's going to be really hard for us to see when it's dissolved or not. I'm going to label this 20% Gelma. Okay, it looks like this gelatin's done, so I'm going to hold off on that. We know how much is in there. Okay, so I need 1.815 mLs of the photoinitiator buffer, which we already made here. So you got to make sure you choose the right one. Like, right, some of these, it might be wise to put some of the other things away that you know you're not going to use. So I'm going to try to accurately measure 1.815. Okay. And the other thing I should mention is this may blow up in my face and not work at all, and that's okay because that is the nature of research. And you're seeing it's not really dissolving in there. So let's go ahead and I'm going to see if I can take a peek. Probably not because I taped it down. I'm going to go over here. If you're good at this, you can slide it out and see what's going on, right? There's some liquid in there, and there's some that's got wet, and it's going to need all that to get wet to dissolve. Okay, so this is going to be a definite challenge, but we're going to try. So I'm going to go ahead and stick this in the water bath. I'll lower that down there as much as I can. And we will heat that up and hopefully it will dissolve. Right now we're about 75-ish degrees, which is a good temperature to dissolve gelatin. It will dissolve pretty quickly. I'll go ahead and weigh out the rest of the methacrylated gelatin and see how much we have. I'm going to go ahead and stick it in a 50 ml tube this time, so let me go get a 50 ml tube. That way there's more room. Stick the tube on there. We will tare it to 0. And then we can fill the tube with the methacrylated gelatin. So we can argue this is probably what I should have done in the first place. Just used a 50 ml tube to weigh out the gelatin. Because it's so expensive, I'm trying not to throw any of it away. Okay, so I have 859 milligrams. So I actually have more gelatin than I thought I would have. 859 milligrams. Again, I'm going to quickly cover this with foil because it is photosensitive. Okay, good. So let's check on the progress of this a little bit. Okay, you can see it is dissolving quite nicely now, which is good news for us, okay? So I'm going to keep that like that. What I'm going to do then is, so that was actually quicker than I expected it to dissolve, so that's really good news. And so as I said, we had 860. We want to make this at 20% as well. Okay, so what I'm going to go ahead and do is just put in 4.3 mLs of the photoinitiator buffer into here. So I'm going to go ahead and use this one because I think we can get about 4.3 mLs pretty reliably. Okay, 4.3. There it is, 4.3. Quickly do this so it's less exposure to light as possible. It's leaking on me. And we'll go ahead and put this in the water bath as well. Try to squeeze it down in there. Okay, so while we're waiting for methacrylated gelatin to dissolve, let's talk about what we're going to do. So we're going to have two more cases in our plate. Number one, we're just going to have 10% methacrylated gelatin, right? And so you remember I'm dissolving this at 20%. So I'm going to need to add some more photoinitiator buffer to some of it in order to make the 10% solution. The other one I'm going to do is mix it half and half with the agarose. Again, so it's sort of a comparison between just physical cross-linking versus physical and photo cross-linking, and we'll see what happens with that data. So now I'm going to start to clean some of the stuff up that we don't need, and I'm going to get out a couple more tubes and label them. Just a note, I'm throwing this stuff away that I'm cleaning up, right? This is recyclable, so I'm definitely going to recycle that. These things I'm going to go ahead and throw in the biohazard, although they're, it's agarose and gelatin, it's not really that biohazardous, but stuff could grow in the gelatin. And then, of course, I always want to throw these pipette tips in there, whether they're bad or not, because the cardboard will help it from poking through. Like if it's just in a plastic bag, and the cleaning person picked it up and all these things poked out, that would be a problem. So that's why we throw those in the cardboard biohazard box, whether they're biohazard or not. And then my empty glass vial of this gelatin methacrylate, right? I'm just going to put it in the glass trash box. Okay, that belongs in there, right? Only glass goes in there. You notice I put some other warnings here, right? Pipette tips are not glass. We don't put trash in there. We don't put biohazard in there. It's just for glass containers. And, honestly, I probably should have taken off the plastic top and thrown it into the regular trash. But I'm not going to dig back through there because there could be broken glass. Okay, so I got a couple other tubes out that we're going to use, right, where we're going to mix the agarose and the photoinitiated gel methacrylate. So I'm going to label these so I know which one's which on each of these. So yeah, when you're working with photo polymerization, you're going to use lots of aluminum foil. I'm just starting to pre-label these things so that when the time comes, we know exactly what's in them. So one of these is going to be 10% Gelma. The other one I'm going to call Gelma plus agarose A plus Gelma. How about that? Just go ahead and check on the progress here. Okay, I'm real happy with that. That pretty much is dissolved in the photoinitiator buffer, so we're good there. Let me look at our 50 ml tube. I'm just doing this because it's it's in the dark a little bit more, so that's a little better. You can see there's a lot of bubbles going on, and that's pretty typical when you're dissolving stuff at high concentrations. So once it gets hot enough, all those bubbles will kind of help it sink. It'll sink down, and we won't have to worry too much about the bubbles. Okay, so I spent some time cleaning up everything and getting everything ready. I think we're finally ready to go ahead and make these methacrylated gelatin hydrogels. We're going to see how they work. I am partially confident they'll work, and partially confident they may not. Okay, so first, as I said, I'm going to transfer everything from the 50 ml tube into the 15 ml tube. Again, I'm just going to do that over here in the hood because it's darker, not because there's any danger. And these aren't really sterile, so it's not the goal we're after is sterility. Okay, and so you can see it's very sticky. We might even lost some in the packaging. I'm not going to worry too much about that because there's not a whole lot we can do about it. But I think we do have our solution in there. It looks like it's about 5 mils total, which is plenty for us. I'm going to stick it in the water again. I'm going to add just a little bit more water to make sure it's underwater always. Okay, so I went ahead and got our gel plate out of the fridge. You can see it is all hardened there nicely, so our gels are looking good. So for these, I am going to cross-link them. Okay, I'm going to use, to cross-link, I'm going to use my super bright flashlight, right, that is ridiculously bright, and so I'll just kind of put it over, and that will cross-link it. And so first we need to make our solution, right? So in these, I put 3 mils each. I'm going to try to cheat a little bit and maybe only use 2.5 mils in each of these, just because I want to make sure I have enough methacrylated gelatin. I don't want to mess around with not having enough. I'm going to be very careful about not losing any. Okay, so let's just start off. First of all, we're going to make our 10% methacrylated gelatin solution. So I'm going to take the 20% out of the hot. Actually, I'm going to look at it for a sec. Yeah, we're in good shape. It's all dissolved. Okay, and like I said, I want to get about 2.5. So I need 1.25 of this. I'm going to go with 1.3-ish. I got some bubble. So okay, that's hard because I got some bubbles. So I'm going to start kind of over. I'm going to go down till I get 1.3-ish. Very good. Okay, put 1.3 in here. And now I need 1.3 mils of the photoinitiator buffer, right? Not water in this case, right? Because the thing we want to do is cross-link it. So I'm going to quickly move over to the photoinitiator buffer, right there. I got a bubble in there too. Okay, 1.3 mils. Now I want to mix this. Again, it's going to be a little bit hard to do. I can't see it, so I'm actually going to go ahead and pull it out so I can see it. We're going to be very quick about this. All right, because this should be 10% methacrylated gelatin. I'm going to suck it up. All right, try not to get any bubbles. We're close to 2.5. Okay, all those bubbles are not good. I'm going to try to suck them up the best I can. Okay, so you can even see it's kind of red color because of the ESMY. And now I want to crosslink with the light. And we're going to hope and pray this works. So I'm going to turn on the light. I'm going to leave it there for approximately 2 minutes. So let's look at the clock. We're at 55:12 right now. So I will go for 2 minutes. All right, that was exactly 2 minutes. I'm going to check this out. Did it form a gel? And you can see it did. The edge is not quite much, but it did form a gel, and in the middle, which is where we're going to do our testing. So I am a little bit shocked and very happy. So that worked out well. Okay, so our 10% gel worked great, and now we're going to do the same thing where we use both agarose and gelatin. Okay, so again, I'm going to go ahead and get out just a little bit here. Make sure it's still good, yep. So I said 1.3, it's about right. Okay, and I'm going to keep this warm. And now we need 1.3 of our agarose. There we go. Again, I'm going to make sure I can see and mix this up. I'm going to do this fairly quickly because the agarose will want to harden itself. Okay. Stick it in here. Again, I got to get rid of the bubbles. Okay, and I'm going to crosslink again for 2 minutes, and we're right at 59:30. Okay. Okay, and that has also been exactly 2 minutes. And you can see we do have a hard hydrogel